I'm teacher Nutan Karadikar, as you know, from Father Ragnal Technical High School, teaching you science. Today we will continue lesson number 10, that is force and types of forces. See your screen. You can also refer to your textbook to page number 71. And before we forget, please like and subscribe my channel Nutan's Academy. And please recommend to your friends in other schools as well. So let us start the chapter force and types of forces, and let us understand what is a gravitational force. See your screen now. If an object is thrown upward by applying force, it reaches a certain height and comes down again. Why is this so? Why do fruits on trees fall to the ground? The earth pulls all the objects towards itself. Now here they have shown one tree and they have shown a fruit falling from the tree. And they have also shown one child, one boy like you, playing with the ball. And the direction of the ball first goes upward in the sky and then it keeps on dropping to the ground. So why this is happening? Why things go up and then again get attracted down? It is all because the earth pulls all the objects towards itself. The force applied by earth to pull objects towards itself is called gravitational force. So we have learned from lower classes that we all are on this planet earth and the earth acts its force on all of us. And that is why we are on the earth and we have some weight. So because of this pull of the earth, we are there on the earth and we can't move out from the earth. All the objects will fall on the earth. Now this law is known as the law of gravitation. It was discovered by one scientist. They have shown a photo of a scientist, this scientist. His name is Sir Isaac Newton. I'm sorry. In the past, Sir Isaac Newton discovered gravitation in the 17th century. The Earth's gravitational force acts in a direction opposite to that of an object, moving upwards. Hence, the speed of that object goes on decreasing till in the end it becomes zero. Then the object starts falling down instead of going up any further. While falling, its speed goes on increasing all the time due to the gravitational force. So while falling also the speed goes on increasing when it is falling down to the earth. So this law of gravitation was found by Sir Isaac Newton. He discovered it. That means he was sitting under an apple tree. You can read the story on the net. He was sitting under an apple tree and he found that the apple fell down and he kept on thinking on it. Why did it go down? Why did it rise up? Because of this curious mind of Newton, he kept on doing some research, thinking over it and building hypotheses. And finally, he came to a conclusion that the earth pulls all the objects towards itself. And this is known as the gravitational force of the earth. So you can go in the library also. Now libraries are closed, but you can search on the internet also. How did Isaac Newton discover this gravitational force? So you all should have a curious mind to find out how this gravitational force acts upon the objects. Now let's go to the next page. Here they have shown us simple experiments in figure 10.6 and 10.7. Now you can see this to yourself. A bucket is full of water and a child is dropping a stone in the bucket. And first of all, in the first time he is throwing the stone from 100 centimeters and in the second time he is throwing the stone in the first time he's throwing the stone about 20 centimeters, and in the second time he's throwing the stone from 100 centimeters of height, and he's observing the sounds. Now what you will understand from this? From this we understand that in the second attempt the stone will make a more sound and it will displace more water than when it is thrown from a lower height. So this is simple experiment. This also shows that there's gravitational force acting on the stone. Now in the second picture they have shown one man carrying a load in a sack bag. Actually he must be some worker and he's carrying a sack on his back. In the second case he is shown fully bent with the sack of the back on his back. It is slightly heavier, and the first look, see, it is empty, it is not full. So the second case, that means the bag looks full and it is difficult for him to carry. So whatever he is carrying in the bag, the second bag is, because it is full, it is heavy for him to carry. So here also the gravitational force on the bigger sack is greater. In other words, we can say the bag weighs more in the second case, whereas in the first case the bag is empty and it weighs less. So weight, how do we decide the weight of an object? We decide it because of the gravitational force acting on that bag or on anything. Now see, in the box they have drawn a conclusion. Gravitational force must be applied to lift a greater object. So if you want to lift this object, you have to apply greater force to lift the object which has greater weight. Now this part, do you know? You read it to yourself. It's a simple experiment and which shows what is the weight of an object, how we decide the weight of an object. And here they have shown, find out and discuss. The gravitational force operates between the sun and the planets in the solar system. Because of this, the planets revolve around the sun. At the same time, gravity also operates between planets and their satellites. Then, why don't all the planets and satellites fall towards the sun? So this is also a question to be asked. There's some kind of forces acting between them, and that is why they are suspended in the space, and they have their internal forces of revolving, and that is why they don't fall, all the planets and satellites, they don't fall on the sun. Yes, use your brain power. So this is also, you have to think with your curious mind. Which forces are acting upon the aeroplane taking off into the sky? So when the aeroplane is taking off into the sky from that runaway, which force is acting on it? Of course, gravitational force. Now the next type of force is the magnetic force. Now what is magnetic force? Place a magnet on a table. Take a big iron nail towards the magnet. It sticks to the magnet. Now hold the magnet upright in the air, away from the nail. What happens? The force exerted by a magnet is called magnetic force. Now here they have shown one bar, and they have also shown that this is a bar, one side is North Pole and the other side is South Pole. So here magnetic force is used to find out. Sometimes this magnetic needle is used in the mariner's compass to find out the north-south direction. So this is also a simple experiment you can do at home. The next force is the frictional force. Now the best example of frictional force is shown here. They have shown you a carom board where you play carom with the striker. Now unless you strike the coins with that striker, that coins are not going to move. Yes, so the striker is given. You have to strike the coins with the striker, then only the coins will go in the pockets. See what it is said here. When a carom piece is flicked lightly, it slides over the carom board but stops at a certain distance. Then why does it stop? It is because the frictional force. A ball rolling over flat ground stops at a certain distance. Why does this happen? When two surfaces rub against each other, the force is friction comes into play. It always acts against the direction of motion. When a brake is applied while riding a bicycle, it stops after running at short distance. How does the brake work? Between which parts of friction is produced? So this friction is there. Because of frictional force, we are able to walk and we don't slide over oily surfaces. If on a surface if there is something slippery, or you can say banana skin is there, we will slip on an oily floor, or on a wet floor. And if we put our feet on the banana skin, we will easily slip, because there the friction becomes zero and we require a rough surface to walk properly. It is possible to walk only if there is little friction, and that is why there are in the railway stations where there is slopes to climb. They have the slope is not made very smooth. They have made some sort of rough so that we can walk properly and climb the slope. And here also, when we are playing carom, we sprinkle one powder. You know which powder it is? Yes, boric powder. That powder we have to sprinkle on the board of the carom so that the coins move with less friction and they can go easily in the pockets. You must have observed the players playing. They always dust the board of the carom with the boric powder. The next kind of force that we have to learn is electrostatic force. Now this electrostatic force is very interesting. You can do it to yourself at home also. See the child shown here. What does he is doing? He is taking a small comb. He has rubbed the comb on his hair, and after rubbing the comb on his hair, he has taken small pieces of paper and he is trying to attract the small pieces of paper through this plastic comb. The comb is made of plastic. So here we can see attraction between the small pieces of paper. Why does this happen? This happens because of this electrostatic force. You can also take one balloon. During your birthdays you bring balloons and you blow the balloons. Now if this balloon is rubbed against a silk cloth, and if it is brought close to small pieces of thermocol, it will attract the small pieces of thermocol. It will also attract small pieces of paper. Why? Because there is some kind of special force which is there created by rubbing, that is called as electrostatic force. Electrostatic force. So this small experiment you can do. Electrostatic force. Down they have given this in this box. Static electricity is produced on materials like rubber, plastic and ebonite due to friction. The force exerted by such electrically charged materials is called electrostatic force. Now you can produce this electricity at home on materials of rubber, plastic and ebonite. I have told you have to take a plastic comb. You can also take a peacock feather. You have to rub the peacock feather between two pages of your notebook, and then you have to bring it close to the paper. You will see that the paper moves. Or you can bring it near to your skin of your hand, and you can see the feathers, the fine feathers of the peacock also moves. this is also called as some sort of force is created between the feathers because of rubbing. So this is called as electrostatic force. Now you know there are some sort of combined forces acting on certain objects. While an action is taking place, various types of forces act on the object in question. You might have seen a roller coaster or juggling of a seaboard on the seashore. Now we go in the melas, yes, in Jatra, we go in melas, no, which is called as fair, Bandra fair or some other fair, and we sit in the roller coaster. We see, after sitting in the roller coaster, we see that the roller coaster is moving, and because of the movement of the roller coaster, there is some sort of 2-3 forces acting on it. Then only the roller coaster moves. First is mechanical, then they add some fuel for the things to move. Then the giant wheel also is moving. Why all these things are moving? It is because of the then again gravitational force is also acting on all these things, and that is why 2-3 forces, when it is acting together, it is called as combined forces. A variety of forces act together in these cases. To obtain more information, you can go to the website called as Trick Science. So this is your homework. You have to go to the website of Trick Science. They have given this address, Trick Science. This website, you go, visit to this website and search on the Google Chrome on this internet and find out what are the different tricks of science, or which are the combined forces. You can type combined forces and search for it. Then in a small fun activity they have given you, they have told you to cut fishes from colored plastic sheets. Take a plastic sheet, colored one, and make small fish and cut it and fix a pin on the other side of the fish. Pin means a small steel thing, you have to fix it. You can take the pin which is there at home where you put for your books, no, such plastic pin you take, and you fix it on the other side, and take a bowl of water and let the fishes swim in that water. Now what will happen? If when you release the fishes, they will all float in the water, and then you can take a magnet and you can move it around the water with the help of the magnet. So those fishes also will move because there is attraction between the magnet and the pin, because pin is made of steel or iron, so it is going to move according to the attraction. So this is a game you can also do at home and enjoy this activity. Show to your parents also. See, this is the fun activity which you can do and enjoy, and show everybody, small kids at home. Okay, now what we have learned, these points you write down in your notebook also, very important. What we have learned, 2 points they have given us. Force is required to bring about any action. Force is necessary for making an object move, to change the direction of motion, and also to change the shape of an object. There are various types of forces such as muscular, mechanical, gravitational, magnetic, frictional, and electrostatic force. So these are the things we have learnt, and let us come to an end of the lesson. We will meet in the next class where we will write the question answers. I will try to make a video of this question answers also, or if I get time I will type it down, all these questions, in a Word document. So here also this question answers we will write it down in a Word document, or if possible I'll make a video of this also. Thank you class. See you. Remain indoors and take care of yourself. Thank you.